Good day, students. Today, we want to consider an experiment to demonstrate a voltmeter connected in parallel with a resistor or a load, which is trying to form an electric circuit. In the course of forming this electric circuit, the bulb will glow to really verify the experiment as being a very good experiment. It's an Ohm's law experiment that involves ammeter that is used to measure the current flowing in the circuit. It has the positive terminal and negative terminal. You can see it. Positive is painted red, negative painted black. Likewise, voltmeter is used to measure the potential difference or voltage between 2 points in an electric circuit. It has its rating V in it, ammeter A, and it has positive terminal red, negative terminal black. And don't forget that voltmeter will be connected in parallel with the resistor or the load, while ammeter is connected in series with the circuit. I'm going to take the measurement of the voltage across this load. Is that okay? You can see the ammeter, the reading of the ammeter will also be taken. It's connected in series. We have the switch, which is the key. It has no polarity. The battery, when you have two cells being connected together, forms a battery, which is one of it. It is cell, called a cell, and it has a positive and negative polarity. Positive is for the longest line, negative is the short line. And in the battery, you have the positive terminal, everything positive is shown on it. The protruded part that comes out, the head, that's the positive. The one that goes inside is the negative terminal. We have the bulb as our load. It will glow to show that the Ohm's law is being verified. We have the rheostat to adjust the current flow in the circuit. Is that okay? If you want the bulb to glow very well, you reduce the resistance. Is that okay? If you want the bulb to reduce in the intensity of the glow, you increase the resistance. Is that okay? Now, what is Ohm's law? Ohm's law says that the current flowing through a metallic conductor, e.g. wire, is directly proportional to the potential difference between its end, provided that the temperature and other physical conditions of the conductor are kept constant. What it's trying to say is that V is directly proportional to the current. If you want to know the resistance, introduce your constant. V equals to R IR. Okay? Look for R equals V over I. You tabulate your readings on this. If you want to get the resistance, you plot V against I. The graph, you will get several readings of the voltage and the current, corresponding current to it. You need to get your resistance, the slope of the graph. Is that okay? Which is the resistance value. Now, I want to carry out the experiment now, but before then, let me explain. This rheostat is for this, but we are going to bypass it because we are not looking for these readings. I just want to show you how the bulb glows. That shows that the experiment is being verified. I will bypass it. I will connect it from the positive of the voltmeter to the key directly and leave this. Just know the purpose of the rheostat is to adjust, to vary or adjust the intensity of the lights or adjust the current flowing in the circuit. You can see it. This is a wire. The conductor is inside the wire. This is an insulator to protect the wire. Now let's start the experiment now. And don't forget that the voltage with the voltmeter is connected in parallel with this resistor. How do you know it's connected in parallel? The current starts flowing from the positive side, most like this, comes here. When it gets to this point, it divides. That makes the voltmeter to be in parallel with this, with the load. Okay, resistor or load. Now let's start. We are starting from the key. Key has no polarity. Connect your wire. Remove the key so that it's not run down the battery. That's one of the precautions. And when you are tightening the wire, make sure the insulator is not tightened up with the knob. That's it. Let's look for good wire that is exposed. Okay. Now from here it goes from the key, it goes to the negative part of the battery. Use your sellotape to hold it. From negative part of the battery, from the positive side of the battery, it goes to the positive of the ammeter. From the negative of the ammeter, it goes, let's leave this bulb first. From the negative, it goes to the negative of the voltmeter. From the negative of the ammeter, you can see it, negative of the ammeter goes to the negative of the voltmeter. Negative of the voltmeter. Now from positive of the voltmeter, it comes here to the key. If you are carrying out the experiment to get the series of readings for the ammeter and the voltmeter, you can now connect the rheostat has no polarity. You can connect this part, the wire to this part from the voltmeter, connect it directly to that, and connect the other side, which is this point, to the key. Get series of reading. But in this case, I just want to demonstrate how it glows. Okay, from the positive of the voltmeter comes to the key. So jump to this key. We are still going to pick from that voltmeter to one end of the load and the other negative to the other end of the load. Now from the positive of the voltmeter to the key, the other side of the key. Okay, now from the positive of the voltmeter to the load, you can see to the load, you can see the point to the load, positive of the voltmeter to the load. Voltmeter to the load, and negative of the voltmeter to the load. Okay, now let's now test it. You see how it glows. This is demonstration of Ohm's law. Ohm's law states that the current flowing through a metallic conductor, e.g. wire, is directly proportional to the potential difference between its end, provided that the temperature and other physical conditions of the conductor are kept constant. You can see it. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.